we continue to look at the Pascal's Triangle. Now, here's a screenshot of what we were doing in the last video. We expanded these binomial expressions when we have x plus y raised to the power of 1. Well, of course, all you get is just x plus y. X plus y squared. That led to x squared plus 2x plus y squared. X plus y cubed led to x cubed plus 3x squared, y plus 3xy squared plus y cubed. X plus y to the fourth led to x squared to the fourth plus 3x cubed, y plus 3 plus 6x squared, y squared plus 4xy cubed plus y to the fourth. Alright? And we saw that the coefficients, the numbers that multiply x and y, it was 1 and 1. So you had 1x, then 1y. 1x squared, which is this one, 2xy, and then 1y squared. And you saw that 1 plus 1 gives you 2. Then you had 1x cubed plus 3x squared y, which is this 3, plus 3xy squared, which is this 3, plus 1y cubed, which is this 1. Then 1x to the fourth, which is this one, plus 4x cubed y, which is this, plus 6x squared y squared, this is the 6, plus 4, this 4, xy cubed, plus 1, this 1, y to the fourth. At the same time, 1 plus 3 gives you 4, 3 plus 3 gives you 6, this 3 plus 1 gives you this 4. Alright. Now, let us look at these coefficients. You notice here that this is an x. It's really x to the 1. So, suppose I should write this x, and I say it is x to the power of 1. Here, is plus y to the power of 1. So you have plus y to the 1. Now, you can imagine that there is a y here, and there's an x right here. But the y is raised to the 0, and the x is raised to the 1, because what you could do is say this is a x, y, x to the 1, y to the 0, and this here is a y to the 1, but it's x to the 0. So let's write it that way. It's x to the 1, y to the 0. So we have x to the 1, y to the 0, then x to the 0, y to the 1. Alright? So that came from the first expression we have here. It's x plus y. But we could include both x and y in each term. Now what about this? The second one. You have x squared, but no y. So let's write x to the 2, y to the 0 power. So what we have here is x to the 2, y to the 0 plus. Now the other term says 2xy. So you could write it as 2x to the 1, y to the 1, because we want to show all the powers. So what you have here is 2x to the 1, y to the 1. You notice it is the same as 2xy. It's just that you don't want to show the 1 there to crowd the writing too much. And of course, you know that once you see x, it means x to the power of 1. This now is y squared. If we put an x there, we'd have to say x to the 0. So let's do that. Plus x to the 0 y squared. So you see that x to the 0 y squared. Alright, let's go to the third line. It's x cubed, but we want the y to be shown too. So what we would do is write y to the 0. X cubed means x cubed by 1, which is x cubed y to the 0. So that's what we're going to write. So it's x cubed y to the 0. So this is x cubed y to the 0. You see that? Plus what now? Let's see. This is 3x squared y. Which is 3x squared y to the 1. I want to show the 1 there. So it's 3x squared y to the 1. So this is 3x squared y to the 1. So it's 3x to the 2 y to the 1. Plus what now? This is 3x y to the 2 to the power of 2. So you could write it as 3x to the 1 y to the 2. So you have 3x to the 1 y to the 2 plus, then you have y cubed, which is the same as x to the 0 y to the 3. So y to the 3 is the same as x to the 0 y to the 3. So let's write it that way. X to the 0 y to the 3. Let me write back that 0 again. Should be superscript 0. So it's x to the 0 y to the 3. So you see that is for this. Let's go to the fourth line now. This says x to the 4th, but we could write it as x to the 4th y to the 0. So let's do that. So what we have is x to the 4th y to the 0 plus, and this says 4x to the 3 y, which is the same as 4x to the 3 y to the 1. So what we have is 4x to the 3 y to the 1 plus the next one now, 6x to the 2 y to the 2. Alright, so we have 6x to the 2, so erase this dot here, and then y to the 2. So we see that. And this is 4x y to the 3, but we write it as 4x to the 1 y to the 3 because we want to show the power. So it's plus 4x to the 1 y to the 3 plus what else now? Plus y to the 4th. So we write plus x to the 0 y to the 4th. So it's x to the 0 y to the 4th. So you see that. Now notice that the numbers before the x and y are 1 1 just as before, 1 2 1, 1 3 3 2 1, because there's a 1 here but you don't bother to write it. 3 3, well, it's a 1 3 3 1. There would be a 1 here too. You don't bother to write the 1. So it's 1 3 3 1. So it's 1 3 3 1, 1 3 3 1 as shown here, and then 1 4 6 4 1, 1 4 6 4 1. So the thing is this now. You see the numbers written here. I could draw this in the shape that I'm looking at here. Is the shape of a triangle. This triangle is what they call Pascal's triangle, because as you see, the numbers, the coefficients, they get wider at the bottom as you go down because you have more terms. At the top it's narrow, at the bottom it gets wider and wider, so it forms a triangle. And those numbers that multiply the x and y are inside this triangle, right? And the shape that they form, which is a triangle, is called Pascal's triangle. So that is Pascal's triangle. And you could use it to get the next expansion. Remember what these expansions were now. This was x plus y to the 1. This was x plus y to the power of 2. This was x plus y to the power of 3. This was x plus y to the power of 4. Suppose you want x plus y to the power of 5. But you can't be bothered with expanding everything from scratch, right? Because it would be a lot of work, very hard work. What you would do is just follow the pattern. Let's follow the pattern and see what would happen. Each term, you have xy. So you have xy. Notice you have two of them here, then 3 and 4, then 1, 2, 3, 4, 5. So when you have to the 2, x plus y to the 2, you have 3 pairs of xy. X plus y to the 3, you have 1, 2, 3, 4 pairs of xy's. Right? You have the x to the 3y to the 0, that's 1. You have the 3x squared y to the 1, that's 2. The second, the third is this one, the 3x to the 1 y to the 2, and the fourth is the x to the 0 y to the 3. Then when you have x plus y to the 4, how many pairs of xy's you have? You have 1, 2, 3, 4, 5 pairs of xy. So that's telling me that when you have x plus y to the 5th, it's like when you have 1, 2, 3, 4, 5 of these, you should have 6 in the next. So you have xy, 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 xy. Alright, you should have 6 pairs of xy. Now, the thing is, you have the first term x to the 1, 2, 3, 4. You should have the first term as x to the 5th. Now notice that when you add the power of x and y, the sum remains the same in terms of x plus y to the 2. 2 plus 0 is 1. Is 2. 1 plus 1 is 2. 0 plus 2 is 2. The powers added here, when you add the powers, it's the same. 3 plus 0 is 3. 2 plus 1 is 3. 1 plus 2 is 3. 0 plus 3 is 3. When you have x plus y to the 4th, the powers, when you add them, 4 plus 0 is 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4. 0 plus 4 is 4. So when you have x plus y to the power of 5, they should add to 5. Now notice that the power of x starts high and goes down to 0. 4, 3, 2, 1, 0. 3, 2, 1, 0. So the power of x goes down by 1 each time. So the power of x goes from 5 to 4 to 3, 2, 1, 0. The power of y starts from 0 and goes up. 0, 1, 2 here. 0, 1, 2, 3. 0, 1, 2, 3, 4. So the power of y starts from 0, 0, 1, 2, 3, 4, 5. And then you can check to make sure that they add to 5. 5 plus 0 is 5. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5. 0 plus 5 is 5. Good. So you have the x and y and the powers taken care of. Now, it's time to put in the coefficients, the numbers that multiply the x and y. Pascal's triangle. Now, what happened? When you look at the numbers that you have here in Pascal's triangle, you had 1, 1, then 1, 2, 1, 1, 3, 3, 1. I'm looking at these 1, 3, 3, 1. 1, 4, 6, 4, 1. So the next is 1, 4, 6, 4, 1. And notice you add 1 and 2 to get the 3. You have 1 and 2 gives you the 3. 2 and 1 give you 3. 3 and 1 give you 4. 3 and 3 give you 6. 3 and 1 give you 4. What should you have next? It would seem like this should start at 1. It would end at 1, as in the case here. But guess what now? The next numbers. 4 and 1 is 5, so this should be 5. 6 and 4 is 10, so this should be 10. 6 and 4 is 10, this should be 10. 4 and 1 is 5, this should be 5. So in the expansion, what you have is 1, 5, 10, 10, 5, 1. And you add everything together. So, and oh, there's an addition here. So this would be x plus y raised to the power of 5, following the pattern from the previous expansions and using Pascal's triangle. Alright? Now, we're going to continue by looking at x plus y to the 6th power next time. But we'll do it in a different video, so I will see you then.